All right, let's get cracking. We are going to talk about adding, subtracting, and multiplying radicals. So when you add radicals together, the thing that I want you to know is that adding radicals behave in basically the same way as adding anything with a variable in it. Like for example, if I did 3x plus 2x, I would be allowed to add those together. Those are what we call like terms. 3x plus 2x then would be, this is not a trick question, 3x plus 2x is?
5x.
5x, perfect. Okay. What I wouldn't be allowed to add is if I did something like this, 3x squared plus 2x. Not allowed to add those two things together. Why not?
Because they're exponents.
Yeah, because the exponents are different, which means they're not like terms. I cannot combine those. Adding and subtracting radicals works in exactly the same way. If I were to give you two radicals, like 7 root 8 plus 3 root 8, I am allowed to add those two things together because they have the same radical. They're both root 8. So I'm allowed to put those two things together, and just like when I added my variables, the x did not change. I had 3x, I had 2x, my final answer also had x. In other words, my final answer wasn't anything weird like x squared. I just left it as x. Same thing here. 7 root 8 plus 3 root 8 is going to be 10 root 8. That's it. I'm allowed to do it if the radical is the same. Just like variables, I'm not allowed to do it if they aren't the same. For example, 7 root 8 plus 3 root 6. I can't add those two things together because they are not like terms. That is not the same radical, so I can't put them together. And this is true even if it's not a square root. These were square roots, but I can do it with cubed roots also. For example, if I did, let's say 4 cubed root of 5 plus 2 cubed root of 5. What do you think the answer to that might be?
6 cubed.
About 6 cubed root of 5. An excellent guess. Very good. And not only does it work no matter what the root is, but it works no matter what is inside the root. For example, if I did 5 cubed root of 3x plus 7 cubed root of 3x, my answer here would be
12 cubed root. I can't even talk.
12
Cubed
cubed root.
3x.
There you go. Yeah, easy. Easy. Okay? What do you suppose the answer to this would be? Four root 5 plus 2 cubed root of 5.
That.
Yeah, it's that. I can't combine these together, but why not? They're both root 5.
Because one's cubed and one's squared.
Exactly right. One's cubed and one's squared. So the answer is that. I cannot put those two things together. Right? So let's try a little trickier ones. You know it's coming. Everybody likes fractions, right?
11. No.
All right. So that one's gross for a couple of reasons. One of the reasons that it's gross is that it's fractions. That's pretty disgusting. The other reason it's gross is because those two roots are not the same. So it's bad for two reasons. But we can fix one of the problems, which is that they're both fractions, by giving them a common denominator. If the denominators are 3 and 4, what would the common denominator be?
12.
Yeah, 12 would be the common denominator. What would I have to multiply this one by to get 12? 4. So times 4 on the top times 4 on the bottom. What would I have to multiply this one by? 3. So times 3 on the top times 3 on the bottom, like that. Okay, so this is going to give me 4 square root of 28 over 12 minus 3 square root of 7 over 12. Okay, great. I suppose technically I could put these together. They're both over 12 now. So on the top, 4 square root 28 minus 3 square root 7, and on the bottom, just 12, right? So far so good. I guess the real question is that the best I can do? And the answer actually is no, it's not the best that I can do, because the square root of 28 right here can be simplified. Oh, you can do it. 4 times 7, right?
Yeah.
28 is 4 times 7. Which means this is the square root of 4 times the square root of 7. Square root of 28 is the square root of 4 times the square root of 7, right?
Okay,
What's the square root of 4?
2.
So this is 4 times 2 times the square root of 7 minus 3 times the square root of 7 all over 12. Okay, I converted square root of 28 into 2 root 7. We learned that last week. There's actually a little bit of simplification I can do here. 4 times 2 is 8. So I have 8 root 7 minus 3 root 7, which is,
5 root 7.
so on the top, 5 root 7, and on the bottom, 12, and that's how we do. I'm a big fan of that problem. That seems like a good one. Okay? You all right about those? Okay. So let's try one with cube roots. So this is the cube root of 7x over 8 plus 2 cube root of 7x. And I'm already kind of thinking that I'm going to be able to combine these. And the reason I'm kind of thinking that is because this has the cube root of 7x, and this one also sort of has the cube root of 7x in it. Like there's that divided by 8, right? But I can see the cube root of 7x in both of these, so I feel like I'm going to be able to combine them together. So I think the first step that I'm going to do, just because I see that those both have cube root of 7x, is going to be to maybe split this apart into 2 different fractions. We also talked about this last week, how the cube root of a fraction, or the square root for that matter, you can separate the numerator and the denominator like that. So that seems pretty good. That seems all right. I can now really see the cube root of 7x, and the only thing keeping me from adding these 2 things together is that they don't have the same denominator. This one has the cube root of 8, and this one's got nothing. So what do you think? I mean, I could give this one a denominator of cube root of 8 if I really had to, but that seems super gross, and I don't want to. I may have to. I may have to give it a cube root of 8 on the bottom, but if I can avoid it, I really would like to. Is there a different way I could write cube root of 8?
On the bottom?
Yep.
Like 2.
How about 2? The cube root of 8 is 2. So really what I can do is I can write this problem as the cube root of 7x over 2 plus 2 cube root of 7x. I like that way better. Now, they still don't have the same denominator because one of them has 2 and one of them's got nothing. So the denominators are still different, but I'm really, really close now because giving this one a denominator of 2 is really simple. What do I have to do to this to make it have a denominator of 2? Let me ask this, what's the denominator right now? What's the denominator of this thing right now? Before I do anything, what's the denominator?
1.
It's 1 before I do anything. Right? So if the denominator is 1, and I would like for the denominator to be 2, What do I do?
Divide by 2 on the top.
Are you trying to hurt me? Do you want to see me cry? Divide by 2? How do I turn 1 into 2?
Multiply.
Multiply! Oh, did you say multiply? Did I hear you right? Or did you say divide and I heard you right and now you're trying to cover for yourself? Multiply top and bottom by 2. That's awesome. What a great idea. I'm glad I thought of it. So the first one is going to be cube root of 7x over 2. No changes there. And this one, I've got 2 times 2 on the top. So 4 cube root of 7x. And on the bottom, 1 times 2 is 2. Whew! Yeah! Okay, I'm feeling good about this. I'm still not done though, but I'm basically 1 step away from being finished. What's the 1 step I still need to do?
Add them together.
Add the numerators and put them over the same denominator. Denominator is 2, so my answer is going to be over 2. What am I going to have on the top? Well, what's cube root of 7x plus 4 cube root of 7x?
4 cube root of 7.
What number's right here?
That'll be 5.
Yeah, there's a 1 right there. So 1 cube root of 7x plus 4 cube root of 7x is how many cube root of 7x? 5. 5 cube root of 7x. Now the last step that I would do if it was possible is reduce this, but since 5 over 2 won't reduce, I'm going to leave it like it is. If this was an even number, if this was like 6 cube root of 7x over 2, I could reduce 6 over 2. Since it's an odd number, I can't reduce, and this is going to be my answer. Woo! Pretty exciting stuff. So what I want you to know about adding and subtracting is you're allowed to do it if the radicals are the same. If the radicals aren't the same, you have 2 options. Either I can't add them because the radicals aren't the same, or I can add them, but I'm gonna have to do a little work to make them the same, like I did in these last 2 problems. So don't just see that the radicals are different and throw your hands up and go, well, can't do it. Because sometimes you can simplify it a little bit. I know your instinct is to just shrug your shoulders and be like, well, this is impossible, I'm gonna skip it. Sometimes it is impossible, but often you can do a little bit of radical manipulation to put things together. Now the reason we started off with adding and subtracting is because the next thing we're going to learn is how to multiply them, and sometimes multiplying them uses addition and subtraction, like this. That is the square root of 3 times 5 plus the square root of 20. Okay. So right off the bat, I've got a set of parentheses and I got a thing outside the parentheses. What does that just make you want to do?
Scream.
Okay, what's the second thing that it makes you want to do?
Distributive.
Yeah, the distributive property is what we're going to do next. So the square root of 3 gets multiplied by the 5 and the square root of 20. So let's do that. That seems like a great idea. So the square root of 3 times 5 is going to be pi square root of 3. Plus, and here's where we're actually going to get to multiply some together. The square root of 3 times 20 is the square root of 60. Unlike adding and subtracting, when you multiply, the radicals don't have to be the same at all. We just put square root of 3 and square root 20 together with multiplication. You can put them together no matter what they look like. What you do, though, is you actually multiply the number inside the radical on both of them. So I end up with 5 root 3 plus the square root of 60. Great. Now what?
Oh, tell me, please.
No, you tell me. That might be the final
I'm here
answer.
learning, so I need you to tell
That
me.
might be the final answer. Or I might be able to add those together. It sort of depends on the square root of 60. What's the highest perfect square that 60 can be divided by? So it can be divided by 1, obviously. What's the next perfect square? After 1.
B divided by 2.
Two's not a perfect square.
Oh,
4 would be a perfect square, right?
4 and 12. Is, wait.
It can be divided by 4, but not 4 and 12.
15.
15, 4 and 15. Is there a higher perfect square? The next one after 4 would be 2 times 2 is 4, so 3 times 3 is,
9.
can 60 be divided by 9? No. Next would be 4 times 4, which is 16. Can it be divided by 16? No. Next would be 25?
No.
No. Next would be 36?
Yes.
No. Next would be 49, and we're getting a little ridiculous. The highest perfect square can be divided by is 4, which means that the square root of 60 can be simplified as the square root of 4 times the square root of 15, which is great news because the square root of 4 is 2. So the square root of 60 is 2 root 15. So let's rewrite that. The first one's 5 root 3, and the second one is 2 root 15. Can those be added?
5 and 2.
Yeah, can the 5 and 2 be added?
Not yet.
Not yet. Can they be added ever?
Maybe
Not
if they're over 3.
Well, maybe if they were both square root of 3 or both square root of 15, but they're not. And there's no way for me to simplify that further. 15 is the best I can do. These are not the same. So I can't do anything else. This is the answer. If I could somehow simplify the square root of 15 to be something with the square root of 3 in it, then we could talk. But I can't, so we're not. Sorry.
Don't apologize.
Well, that's alright. I was just trying to be polite. I don't actually care. Simplifying them will be your problem. Cool? Alright, let's see who's getting kicked out of class tonight. How do I multiply those two things together?
Foil.
Nope, you're the one getting kicked out.
No.
You're the one getting kicked out. It's not foil. Ugh. Why do you hate America?
Some of these can be simplified. No, it's not. Never mind.
No, I don't think any of them can be simplified yet. I think our best chance is 6, and the only multiples of 6 are 1 and 6 or 2 and 3. So, probably not. So what do I do? Not foil. What do I do? Take your time. It has been almost 5 minutes since we've done it. Really? If you're not allowed to call it foil, you don't know what the name is? That's embarrassing.
Distributive?
It's the distributive property, yeah. So let's do it. Let's distribute the square root of 2 first. Root 2 times root 6 is going to be?
Root 30. No. Root 12.
Root 12. Sweet Jesus. And then we will distribute the root 2. Root 2 times 2 is going to give us?
2 root 2.
Good. Okay. Halfway there, the square root of 2 has been properly distributed. Moving on. Negative root 5. Let's distribute that. Negative root 5 times the square root of 6
Negative
is?
root 30.
There you go. And then negative root 5 times 2 is?
Negative 2 root 5.
There we go.
How is that not foil? I don't understand.
Because foil is stupid and the distributor property isn't stupid. That's why it's not
So
foil.
it is kind of the same thing though, right?
Foil is dumb because foil only works if it's a 2 by 2. That's literally the only time FOIL works. So don't say FOIL, because if this is a 2 by 3, FOIL is dumb. If this is a 1 times 2, FOIL is dumb. If it's a 3 times 3, FOIL is dumb. FOIL is only not dumb in this one situation. So this looks pretty gross. Not as gross as someone who says FOIL after being in this class for half a semester, but it's still pretty gross. But I feel like maybe we can clean stuff up a little bit. I know that I'm not going to be able to clean up the square root of 2, and I know that I'm not going to be able to clean up the square root of 5 because those are prime. But the square root of 12 and the square root of 30 have potential. Is there a perfect square that the square root of 12 can be divided by?
No.
Yes.
Oh, wait.
4.
How about 4? The square root of 12 is the square root of 4 times the square root of 3, or 2 root 3. And let's move on to 30. Is there a perfect square that 30 can be divided by?
Brand
3 and 10 are multiples, but neither one's a perfect square. Perfect squares: 1, 4, 9, 25, 16, 49, and your lucky Powerball 36. Any perfect squares that 30 can be divided by?
Say this again?
All of them?
No.
1, 4, 9, 16, 25, 49, and your Powerball 36. The answer is no.
Okay.
None of those will divide into 30. And we turn this into square root of 3, which is good, except none of the rest of these are square root of 3. So there's nothing for me to combine in this problem. My answer, as gross as it may be, is that. I assume there is some sort of math convention that says, like, all good mathematicians put this in order, like from smallest radical to largest or whatever, but I have no idea what it is, and they stopped inviting me to their parties a long time ago, so can't help you there. Any order is fine. There might be a rule, but I don't know what it is. And that's it. That is the answer. It's an answer only a mother could love, but there it is. All right. Let's go hard. Whew, Lordy. That is G-R-O-S, gross. So, it's still distributive property, it's just not the sort of distributive property we're going to enjoy, as opposed to the usual distributive property that everybody loves and appreciates. So 3 root y is going to get distributed. Okay, this is going to
6
be...
root y.
It's not 6 root y, because remember, when you multiply, you also multiply what's inside the radicals.
Y
So it is going to be 6, but it's y squared. Y times y, y squared. 6 root y squared. And then 3 root y times 3 is
9.
9.
Square root of y.
There we go. Good. Okay, so the 3 root y has been distributed. Well done, everybody. We did it. Then we'll do the negative 4. Negative 4 times 2 root y is?
Negative 8 root y.
There we go. And then negative 4 times 3
Is negative 12.
Okay. So negative 12 actually is a little bit of good news, because if it's negative 12 and there's no radicals, I know I'm done with that. There's nothing else I can do with the 12. Finissimo. As a matter of fact, I'm also done with the square roots of y, because that can't be simplified. The only one of these that has a chance of being simplified is the square root of y squared, which is
Why?
y. So this is going to be 6y. Let's go ahead and combine these two while we're at it. They have the same radicals, so I can put those together. What's 9 root y minus 8 root y?
Root y.
That would be just 1 root y, or root y, and then minus 12 on the end. Believe it or not, no part of this can be combined or simplified, so that's the answer. That wasn't nearly as bad as I made it sound like it was going to be. You got bamboozled. Alright, let's see if I can really ruin your life. I mean, more than I already have. That is a good problem. That's a good one.
No, it's not.
This is the kind of problem that you go home and tell your parents about, because they're going to ask why you're crying when you get there. What's wrong, sweetie? Were you attacked? Yes, this is the thing that did it. What do we do?
Distribute the exponent.
Well, yeah, but first of all, what does it mean when something's squared? We do want to take care of the
It's
exponent,
root.
not by
It's
distributing.
the opposite of root.
Yes, but when anything is squared, what does that mean? I'm not asking for a super high level answer here. Very
Times
basically,
itself.
times itself. So what this is actually telling me to do is the square root of x minus 3 plus 5 times the square root of x minus 3 plus 5. That's what I'm actually asking you to do. Cool. Well, it's still distributive property. I know it looks nasty, but it's still distributive property. So here we go. Square root of x minus 3 times square root of x minus 3 is
Square root of x minus 3 squared.
Yep. Like that. And then square root of x minus 3 times 5 is 5 square root of x minus 3. Cool? Cool. I like it so far. We got the first square root of x minus 3 distributed. Now let's distribute the 5. Good. 5 square root of x minus 3. Well done. And then the last thing, 5 times 5. 25. You are so smart. I should take back some of the bad things I've been saying about you behind your back. So now that we've got this done, there's a little bit of cleanup we can do. First of all, hopefully you notice that we've got two things with the same square root, so those can be combined. That can also be simplified. How?
Because the square root is opposite
Uh-huh.
of square.
They are
so
opposites?
It's just going to be what's in the middle.
So what is
So
it?
it's going to be x minus 3.
That is correct. This simplifies to just x minus 3. These two things can combine to be, this is audience participation. 10
X minus,
square root of x minus 3 plus 25. Okay. You know what? I think that's good enough. Unless you see anything else that can be combined.
Minus 3.
We got two numbers that can be combined. The minus 3 and the plus 25 can be put together to get plus 22. So my actual answer is going to be x plus 10 square root of x minus 3 plus 22. And I'm sure that you won't have any problems that are harder than that one. I'm sure that's as tough as they get.